Alright, welcome to Lecture 4, our continuation of our acid and base unit. In Lecture 4, we're going to focus on the pH, what it is, and on the pH scale. The essential questions that we will address is what is pH and how is pH calculated. So to begin with, we're going to look at a simple definition of pH. Essentially, pH is a measurement of the concentration of hydrogen ions in solution. And you can think about, remember, concentration of hydrogen ions is H plus is equal to the number of moles per liter of hydrogen ions that are dissolved. You can also substitute the fact that the H plus concentration is equal to the hydronium ion concentration. Remember that in reality the hydronium ion is the true nature of the acid over the H plus, but you can use either one interchangeably. It doesn't matter. The other thing that you should understand about pH is that pH allows us to understand the strength of the acid, how strong our acid is and how concentrated or how dilute the acid is. The pH is also based on a logarithmic scale, log base 10, as you're going to see here in a minute as we learn how to calculate the pH. So, to calculate the pH, we have an equation. The pH is equal to the negative log of the H plus concentration, or we can substitute H plus for the hydronium ion concentration. Either one would be correct in using. Alright. Now we can also take the pH and take the inverse log of base 10 to find the H plus concentration. To do that, we would take H plus is equal to the inverse log to the negative pH, whatever the pH is. And so you can use this to find the H plus concentration. Go either way. Both these equations and approaches are very important for you to know and understand. So make sure that you have these equations in your notes, and we need to practice them. So let me give you an example. Let's say that you have an H plus concentration of 1.0 times 10 to the minus 6. Now we got to find the pH. So what we're going to do is we're going to take the pH, and I would take your calculator out and make sure that you understand how to plug this into your calculator and get the right answer. So take the pH of the negative log. So you're going to have to find your log button on your calculator and multiply that by the hydrogen ion concentration. And you should end up getting, when you put that in your calculator, it should equal a pH of 6. Alright? So go ahead and plug that in, make sure it works. And we can also let's try the inverse of this. Let's go ahead and take our pH and find the concentration. Alright, so if I had a pH of 6 now, then we're going to find our H plus concentration by plugging into 10 to the minus 6. So make sure that this is the natural log, or the inverse to the inverse to log base 10 in your calculator. That usually is on the same button as your actual log base 10 button. Okay, plug that in, and you should get an H plus concentration of 1.0 times 10 to the minus 6 moles per liter. Alright, so make sure you can get that worked out. Alright, you're going to have to be able to do these pH calculations on the quiz. So be prepared for that, and make sure you bring a calculator and know how to use it, find the log button and so forth. Alright, let's move on. What I would like to do before we get into pH scale is talk to you about important aspect of water. Water itself breaks down to form H plus ions and OH minus ions. Alright? And so anytime you have water, you're going to form an equilibrium situation like this. Alright? Or, better yet, what really happens is water is going to act as an acid, and it's going to react with another water molecule, which is going to act as the base, and it's going to form the hydronium ion plus the OH minus ion. Alright? So, again, our H pluses, or the hydronium ion, is the conjugate acid, and the conjugate base is going to be the hydroxide ion. So, when we look at solutions, what we're really looking at is a measurement of the hydronium ion concentration versus the OH minus concentration. And so, if there is more H pluses, so if the H plus concentration, let me erase this so we can look at this. If the H plus concentration is greater than the OH minus concentration, then the solution is acidic. Alright? So more H pluses than OH minuses, the solution is acidic. On the flip side, if the H plus concentration is smaller than the OH minus concentration, then the solution is considered basic. Alright? With that in mind now, we can talk about the pH scale. The pH scale, again, is a logarithmic scale based on the log base 10. And it runs roughly from 0 to 14, with 7 being in the middle. Alright? And the pH scale kind of tells us how strong our acid is, or how dilute it is, or concentrated it is. And so it's a fast method to look at this. Okay? So what we find is, based on this idea, is that anything that's below 7, pH below 7 is going to be acidic, and a pH above 7 is going to be basic. What that essentially means is that in an acidic solution, as we just mentioned, if the H plus concentration is greater than the OH minus concentration, then the pH is going to be less than 7. So this kind of relates to this idea here. But if the H plus concentration is less than the OH minus concentration, it's basic, right? And so therefore the pH is going to be less than, or greater than 7 up to 14. Alright? And if the acid and base concentration is equal to each other, if it's equal, then the pH is going to be 7, or neutral. Now, the reason why water is at a pH of 7 is because when water breaks down, as we just talked about earlier, the fact is we can go back to that and look at this. When water breaks down, to form H plus and OH minus ions, it forms an equal amount of H plus ions and OH minus ions in solution. Therefore, the pH is equal to 7. Alright? So, by the way, the H plus concentration is 1.0 times 10 to the minus 7. That's what the H plus concentration is, which is also equal to the OH minus concentration. So if we take and plug this into our pH equation, take the negative log, or the negative log of base 10 of 1.0 times 10 to the minus 7, then that equals 7. Alright? So, water has a pH of 7. Equal number of H pluses and OH minuses. Alright, so back to our scale again. Rewrite this out. 0 and 14. 7 in the middle. Everything above 7 is basic. Everything below 7 is acidic. At a pH of 7, it is neutral because we have an equal number of H pluses and OH minuses. Okay? Essentially, you have water, or pure water. Alright, some things also about the pH scale you should understand is that the pH numbers are positive. There's no units to pH. The pH is inversely related to the H plus. That's important to note, and make sure you understand that for the quiz. The pH number is inversely related to the H plus. What does that mean exactly? Well, it simply means this: the smaller the pH is, the more acidic the acid is. So when you're looking at like a pH of 2 versus a pH of 5, the smaller the pH, the more acidic the acid is. So we would look at a pH of 2 as a stronger acid or a more concentrated acid than a pH of 5. So what we could say is the acid strength goes up as we get a lower pH. Now, on the idea then is that as you get a pH of 11 or a pH of 12 or 13, 14, the acid strength is not as good. So that's why let's put an arrow all the way through there. Alright? So again, the pH number is inversely related to the H plus concentration. The last thing I want to look at here on this last thing is a change in 1 pH unit represents a 10-fold increase in the H plus concentration. A 10-fold increase. That's pretty vital to understand. What that means is because the scale is on a log base 10 idea, that when we change the pH by one number, just by one number, it increases the strength or the concentration of the acid 10 times. So for instance, if we go from a pH of 3 to a pH of 2, that's a 10 times increase in the strength or the concentration of the acid. So that's a big deal. In the inverse, if you go from a pH of 2 to a pH 3, then the acid concentration is decreasing 10 times, okay, getting smaller, right? So you need to understand that relationship. Very important. Alright, so let's move on to our last little bit, is how is pH measured? Well, there are many methods, but we're going to look at two very common ones. First of all, most common and easiest is using what is known as pH paper. pH paper is specially treated with what is known as a universal indicator paper. Okay, I'll write this down. pH paper. Okay, pH paper, which is made up of a universal indicator. Alright. And what happens is that when you use that pH paper and you put it into a solution, it changes color. And then we can use a scale to compare the color to the pH. So for instance, if you look at A and you use the scale, you would find that the solution of A has a pH of 1. For B, it would look like it's a pH of 4. For C, a pH of 8, and D looks like a pH of 13, maybe 14 actually. So you can quickly determine the pH of a solution by using this universal indicator or pH paper. The other one we want to look at is a pH meter. Alright, pH meter. And a pH meter gives you usually a digital readout of what the pH of the solution is. This is a little bit more involved, not quite as quick, because you have to set up the meter and calibrate it. Plus the meters have to be accessible, and they're very expensive on top of that. So meters are great if you have access to them, and they give you a very accurate reading of the pH of a solution. But pH paper works just as fine too. It's cheaper, it's easier to carry around, and so forth. So pH paper and pH meters are both acceptable in determining the pH or measuring the pH. However, the pH meter is definitely more accurate. Alright, so there it is on pH. Make sure that you read through these notes that you've made carefully. Be prepared for the quiz that we'll have over this. If you have any questions, let me know. But that is it for now.